In this video, I'm going to show you how to create a blockchain application without having to require your users to hold cryptocurrency like Ethereum in order to use it. All right. I'm going to show you how to do it exactly step by step in this video. All right. So if you're new around here, hey, I'm Gregory from dApp University. On this channel, I teach you how to become a blockchain master. So if that's something that you're interested in, then click the like button down below and click subscribe. And if you want to take that next step to mastering blockchain, you should head on over to dappuniversity.com/bootcamp. All right, so let's get into this. How can you create a blockchain application without your users having to pay anything? Well, today I'm going to show you how to do that with the gas station network by OpenZeppelin. All right. So I've had a lot of people actually ask me about this. They say, hey, will you please make a video on this? Will you please explain this? I've had lots of questions about this inside my program, Blockchain Mastery University as well. So I figured I would just go ahead and make this video. So, I've been aware of this project. I haven't used it a lot really at all on my personal projects or anything like that. So I figured I would learn about this with you and go through their setup steps on how they, say to use this. So I'm going to be learning with you in this video. This will be like a reality TV experiment, but you're going to get a lot out of this by just getting my commentary and watching me do it on screen. I'll explain everything step by step as we go along. So let's jump in and get started. All right, so let's get into this. How can we build dApps that cover users' transaction fees? All right, so let's just really quickly kind of recap what I mean by that. So basically, whenever you're using the blockchain, Ethereum specifically, you need a wallet oftentimes, like this wallet here, MetaMask, and this is going to have a user's account, and in order to use the dApp and create transactions and sign them, the user must hold some cryptocurrency in their wallet in order to pay for those transactions, right? So Ethereum uses this concept of gas, where, that's what the user has to pay in order to, send transactions on the network. All right, so enter in gasless transactions. So, like I said, Ethereum uses this concept of gas. That's what the fee is in order to, create transactions on Ethereum. And, we can actually create apps with OpenZeppelin with the gas station network where we can pay for users' transaction fees. All right. So how does it work? So they use something called meta transactions. All right. So these are basically transactions on the Ethereum network where the user does not need to pay their gas fees, at least directly. And now it still costs money to create these transactions on the Ethereum network. So the real key here is that somebody else is paying for the user's transactions. Okay. So basically, it still costs money to create the transactions, but you're not necessarily charging the user for it. You can charge the user for it in a more roundabout way, which I'll talk about in a second. But in this case, this design pattern basically allows someone else to pay for it with the OpenZeppelin gas station network. All right, so how does that work? So in this case, whenever a user creates a transaction, they can still have, a wallet with an Ethereum address of some kind, but they sign the message, all right, instead of actually creating the transaction. So basically, when a user uses the dApp and they have MetaMask installed, you can click a button and instead of, they can still have sort of confirmation pop up, but the confirmation that they trigger is not really paying for anything. It's not creating a transaction on the Ethereum blockchain. It's just signing a message, all right? So Ethereum allows you to sign messages that are broadcast to the network, and those don't cost money, all right? So that just is a way for them to guarantee that they're the one that sent the transaction, but it doesn't actually charge them cryptocurrency. So instead, a real transaction is later created, but it's triggered by someone else, in this case, a relayer. All right. So a relayer is basically just a process or a network of processes running somewhere else that, are aware of the message that was signed and create a transaction on the user's behalf. And it charges a base contract, the fees instead of the user. Okay. So that's a little tricky, but we're going to watch some of this in action throughout this tutorial as I, work through all this. But the note here is that you need a few moving parts, right? So you need users, and you got a base contract, and then you've also got a relayer. All right, so this relayer must be running in order to make this happen, right? So the user, I guess we'll also put the app here. So the user, signs a transaction, right, to the app, and then also to the blockchain, I guess. And this relayer is aware of this. Sorry, the contract. The relayer is aware of this, and they're the one that actually does the transaction. They pay for it, but then they recoup the cost from the base contract by charging it the actual money. So in order to make this work, you need a relayer or a network of relayers, and that's exactly what the gas station network is. All right, so we're going to see all that in action here in a minute. So they offer some, suggestions on how you could use this inside your application. They say basically, like, it's really common to pay money to acquire new users or give them things for free to get started. But they suggest that, you could charge your users on the back end, for example, like they could enter their credit card, and you could retroactively charge them for any gas fees that you incur on their behalf, just so they don't have to jump through the hoops of like KYCing and buying ether through an exchange or something like that in order to use it. You could still create a dApp that, charged them money, but maybe not directly through an Ethereum wallet or something like that. So they give you lots of, or at least one suggestion on how you might use this. The possibilities are many. So I encourage you to play around with this and, kind of see how you might leverage this in your own application. All right. So let's go ahead and start building out this project. So like I said, I'm going to be, just following through this documentation here, but I'm going to walk you through step by step on how to do this, but this will be the first time that I'm doing it myself, so you'll get sort of a real world reality TV version of this, and also my commentary along the way. So I'm going to enter into my code directory, and I'm going to follow the steps that they give here. So the first thing we do is set up the environment. All right, so it's going to install some dependencies with Node. So if you don't have Node already installed on your computer, you'll want to do that. You can check by going to your terminal and typing node-v. If you don't have Node installed, you can go to your browser and just look up Node.js install, but you'll need that. So go to my code directory here. This is where I keep all my projects, and I'm going to create a new directory like this. So this mkdir just creates a new folder, and this and just allows you to execute a second command, and you enter into this gsn dApp directory here that we just created. All right. So now we can do npm init-y. So this creates a package.json file, and doing the -y basically means that you're just going to say yes to all of the prompting that you walk through. So basically, if you didn't have a -y flag, it would say, do you want to do this? Do you want to do this? Do you want to do this? And this just saves you time from having to confirm all those things. So now we're going to install the Open Zeppelin network package, npm package like this. All right. And while that's going, we'll go ahead and look at the next step. So there are a few other things. This is doing npm install save dev, which will put these in our package.json file. So gas station network helpers, Ethereum package, and then also these Open Zeppelin proprietary upgrades, and the command line interface, and also Ganache CLI. All right. So I'm going to copy these. So if you're copying these from the project as well, like, don't use the $. Installed. Now I'm going to paste in these other ones. All right. So this is going to install these helpers, the contracts, the upgrades, and this command line interface. All right. So that worked. I'm going to clear this out. So now what we do is use the command line interface to set up a new project. So we'll do that like this. We're going to use npx, and OZ is just going to be the command line interface that we installed here for Open Zeppelin. So npx just allows us to execute, I believe, binaries inside of the package, node packages. So that's how we're going to interface with the OS. So basically, we'll say npx OZ init, and then we'll see some prompting here. So you should be able to just confirm, just hit enter on all these things. All right. So we'll see all this prompting, and we can just continue with this. All right. So let's go ahead and open up the project. I'm going to open it in Sublime Text, say subl dot. All right. And here we go. We can see all the files that were created for us by the generator. Let's just take a look here. So we've got the contracts and this node modules directory. All right. So we got our package.json file here. This is what we created when we did the npm init command, and we can see the dev dependencies that we saved. We got the networks here. This looks a lot like a truffle project. All right, so let's go ahead and create this contract inside the contracts directory. So I will say touch, let's see here, contracts, and I'll call this counter sol. All right, so we're going to just copy and paste the code in they give here. So let's go here. Here's our counter.sol file. All right. And this is really simple smart contract. So I'll explain what it does. So first, we declare the Solidity programming language version. This is just 0.5.0. And then, we use the contract keyword to create a counter smart contract. That's what the name is here. And we just have these curly braces, and this is where all of the Solidity source code goes inside of here for the smart contract. So basically, we have just one function called increase. And it does exactly what you think it might. It just takes the value and adds 1 to it. So it's a simple counter. Like, we're probably just going to wire this thing up to a button, and every time we click that button, this value will increase, okay? And then we have this variable here called value. This is going to be the number that you currently, the current number in the counting scheme. So every time we add 1, we'll see this value increase by 1, right? So 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way until we decide to stop pressing the button. So basically, it exposes this value as a function because we call it public, and it's just a unsigned integer, 256. All right, so pretty simple stuff here. That's the smart contract. But now what we're going to do is actually modify this to add gas station network support. Okay, so we're going to extend this thing called GSN recipient here, all right? And this is just going to be a library in Solidity provided by OpenZeppelin that allows us to create special functions that work with the gas station network. So specifically, it's going to say accept relayed call, which allows us to introduce the relayer into the equation in order to pay for the user's gas fee. Okay, so it specifies here this method must return whether we accepted or rejected to pay for a user transaction. But in this tutorial, just for simplicity's sake, they're going to be paying for all the transactions. So that's why they'll just have sort of a default value returned here. All right. So let's just copy this and put it inside the file like this, and we'll just take a look. So here is the original code that we wrote, but we've imported this contract here, or this library from OpenZeppelin, the GSN recipient, and we've extended the counter here. So counter is GSN recipient, all right? And then here's our original function, but we have this additional function here that says, accepted relay call. And it's got all these arguments. I wouldn't necessarily worry too much about understanding what every single argument is, but look at some basic ones here. Here's the relay address. This would probably be for the relayer, address from, who's it sent from, all this kind of stuff, right? So we're going to leave these blank because we don't need to do any pre or post-processing, but I'm sure after you follow this tutorial and you dive in deeper to the documentation, you'll get a better understanding of how these work, and if you need to use them in your own projects, just know that they are there for you to implement. All right, so let's continue on here. Next, what we'll do is we'll start Ganache. All right, we'll actually use Ganache CLI just like they recommend. I'm going to open a new tab here. So you might have seen my other tutorials where, if you've been watching the channel at all, where I use Ganache, the GUI version, right? This nice user-friendly app. But instead, we're going to use Ganache CLI, or the command line interface version. So we'll start Ganache CLI just like they tell us to in another window like this. We'll say npx, and we'll just follow their instructions here. Let's see here, npx Ganache CLI. Sorry, this is a little different than what I normally do in my projects, so I had to just look at the command to make sure I was typing the right thing. So you'll see here, this works a lot like Ganache the user interface version, but this is just starting it up in your command line. You can see all the available accounts here. So this is just a blockchain that runs on your computer, guys. So if you're not familiar with Ganache, that's what it is. It's a personal blockchain for development. And it gives you 10 accounts for free, all credited with 100 fake ethers. It's just, test cryptocurrency. And they expose the private keys. So, if you're watching this video, don't use any of these accounts in production in the real world because someone could steal your money. So yeah, or this mnemonic seed phrase. So anyways, we have a blockchain running, so let's continue on here. So now what we want to do is put the smart contract on the Ganache development blockchain. So what we'll do is follow their instructions. We'll just say npx-oz create. I'm just going to copy and paste it. All right, and this should put it on the network. So we see it's compiling, and then here we go. Let's see here. Counter. All right, so we're just going to walk through all these steps. Counter, yes. Network development. Call a function to initialize instance after creating it. So yes, you definitely want to call the initialize function. Let's see here. All right, initialize, hit enter, and there we go. Boom. So it just walks you through some setup steps whenever you're deploying to the network, but just, confirm all of them. Make sure you call the initialize function, and looks like everything is good. So yeah, here we go. We can see the transactions that were created on the blockchain whenever this was deployed to the network. So yeah, we're doing well. Let's keep going. All right, so now the next step is we need to set up a local gas station network on our computer for development purposes. So just like we set up a local blockchain for development purposes with Ganache, we need to create a local gas station network instance as well. So we'll just follow their instructions. So basically we choose npx again, Open Zeppelin gas station network, and then we just run relayer. So it looks pretty simple, all right? But really quickly, let's just look at their notes. So it says GSN is composed of a central relay hub contract that coordinates all relayed transactions as well as multiple decentralized relayers. So basically, the relay process that receives requests to relay a transaction via HTTP interface and send them. So basically, we're going to have this process that represents the relayer network just like it would in production. All right, so we'll just paste it in here like this. And this should open it on our computer, just like we did for Ganache. Okay, so it looks like everything's working well. We see all this activity here. Let's keep going. All right, so now the last step is that we need to fund the counter contract that we created. And this is key in how this whole process works, okay? So the gas station network relayers, it says they require recipient contracts to have funds since they will have to charge the cost of the relayed transaction plus a fee. So we'll do that here in a second, but basically, just note that how it works is we have this counter contract, but we're going to send money to this counter contract, and that's where the fees are going to be taken from, okay? So whenever users interact with this, they won't directly have to pay for the gas costs, but the relayers will, and the relayers need to make the money back, and so where do they charge it? Well, they charge this contract, not the user directly, all right? And your business may charge the users later with a credit card or something like that, or you might pay for their fees entirely, depending on what your business model is, but this smart contract is where the funds actually go. And so this might be a little confusing if you're new to blockchain development. These addresses here, these are account addresses just like you might see in MetaMask, but smart contracts also have addresses just like this, and they are able to hold cryptocurrency just like human accounts can. And so that's what it's talking about by funding the smart contracts and charging them fees with the relayer. So basically, we'll just send money to this, all right? So what we need to do is put the recipient address will be our actual smart contract. So I'm going to copy and paste this part, but then I'm going to put the address of this smart contract that we created here in the last line. All right, so add some space here. All right, so what this command does is just adds some cryptocurrency to the smart contract that we created. So now the balance is this. Okay, awesome. So it looks like it might be like 1 ether, maybe 10 ether. I'm not sure. If you really want to know for sure, just count how many decimals are behind here. If it's 18, it's 1 ether. If it's more than 18, just keep adding zeros to that. All right, so there we go. The smart contract is set up. We've got the relayers running with the blockchain running. So now let's create a user interface to interact with the smart contract and create a full stack dApp. All right, so now what we can do is create a React app. All right, and we're going to create a client. So I'm going to open a new tab here. So we'll have one for smart contract development, one for the blockchain, and one for the relayer network. So we'll just follow their instructions, say npx create React app client. All right, so client's going to be the directory where we have the code for the React application. So what we're going to do, if you've seen any of my other tutorials, and don't worry if you haven't, React is just a library for building user interfaces in JavaScript. So it's going to allow us to, create something really quickly without having to write a bunch of JavaScript code ourselves with React components. All right, that's how it organizes the code. And we'll be able to see that as soon as this generator finishes. We'll just follow their instructions on how to create the application here in a second. All right, so that's installed. So let's see what the next step here is. All right, so now what it wants us to do is create a symlink from inside of our client source directory so we can access the contract files. So basically, like inside here, this client source, we want to go inside of here and tell our terminal basically that these files inside of here exist and that we can access them from this folder. Because by default, React doesn't allow you to read these kinds of files. So you can create a symlink to handle this. So basically, we're just going to go in here, copy this. So the ln command, that's what allows us to create the symlink. And these are just the arguments for it. And we'll execute this to link this so it can reach it. But we need to enter into this directory first. We go to client source, and then we put the command. All right, so that worked. And I'm going to go back. Well, we can say inside client. All right, so now we're going to open up the app.js file and add the code for the client-side application. So close this, go to client, source, app.js. So inside of here, this is a React component, which is where we're going to put all the JavaScript code for the application. You can see that React uses these components to write all the code. We can see that there is basically this JavaScript code with HTML mixed in, all right? And we're going to add some more JavaScript functions inside of here momentarily. So basically, I'm just going to take the code that they give us and paste it in. I'm going to do it like this. Sorry. Copy on the screen here and put it inside this app.js file. And let's kind of step through it and see how it works. So basically, I'm going to add some space here so we can see this. Here is the app, and we added a bunch of functions here, which I'll walk through here in a second, and some conditional logic. And then basically, we coded out this return function, everything inside of here, the HTML code with some more React kind of syntactic sugar for these components with fragments. And we added those to the app like this. Okay, so I'm going to try to explain more of this in a minute. I know there's a lot going on here, but first let's just try to boot up the application and save this and see if it works. So basically, let's just do npm run start to see if we can get this to work. So we need to be inside the client folder right here in order to make this work. So we'll just say npm run start, and this should open up a new browser window for us like this. And we should be able to interact with our app if everything works properly. All right, so it's compiling. Let's just see if it works. All right, so it looks like we got a problem here. So it can't resolve Open Zeppelin Network React in this directory here. So let's see if we can fix that problem. I'm not really sure what's going on here. It looks like I don't have this in my project. So maybe I missed a step in the tutorial or something like that, but I'm going to try to fix that. So let's just kill the server here. I'm just going to install this npm package. Hopefully it'll work from the client directory. So I'm just going to say npm install save dev, and then pass in this. And hopefully this will fix our problem. Okay, so it's trying to require this React package. Maybe we could install that individually by itself, but I'm just going to install the whole thing inside of here and see if that fixes the problem. So let's wait and see. All right, so the package was added. Let's just see if we can restart the server and make it work again. So I'll say npm start, and it should open the project again. And let's see if the error goes away. Oh, still got the problem. All right, so I just fixed it. Here's what I did to fix the problem. Inside the package.json file, I'm not really sure why I was getting the error, but I went ahead and downgraded Open Zeppelin Network to 0.2.10, at least the version, just higher than that. It maybe. I'm not exactly sure which version I'm using. I could look in the package.lock here. But what I did was I just reinstalled my node modules and restarted the server, and now the app is compiling successfully. So we can go back here and see what we have. All right, this is a basic application. It tells you this is the counter instance for the smart contract. Here's the counter value. All right, 0. Oops, sorry, let me pull this back over here. And then also the counter actions. So basically, we just want to increase the count by 1. Let's click this and see what happens. All right, boom, there we go. We just saw the value go up by 1. All right, so that's pretty impressive. We just created a dApp that can, execute transactions to our smart contract without the user having to pay their gas fees, right? I can even do it again and watch it happen. So let's just go really quickly and look at the app here, see what was provided. So basically, this uses the Web3 connection that's already connected to our Ganache instance here on localhost port 8545, and it basically gives you a connection to the gas station network with Web3. So we have, connection to GSN or gas station network with the development environment true, provided in our Web3 context. Okay, so it pulls all the accounts out of Ganache and also this lib that we created here from this context that we just set up. Pulls in the smart contract with this counter JSON file here, build contracts counter.json. So it loads an instance of the smart contract inside JavaScript here. And then basically, it just sets this stuff up. So basically, if all this stuff exists, if we have a smart contract, if this context was set up correctly, if we have a network ID, then basically we just get a deployed instance of the smart contract here. This looks a lot like Web3.js, where we create a new contract, we give the ABI and the address. So this, this looks kind of verbose, but this is really similar to the other basic ways that you set up Web3 contracts. It just has a lot more, code kind of involved. So basically, we can just get what the current count is, and then also set the count. These are two functions on the smart contract. It pulls these from state. Here's a function that gets called whenever we click that button to increase the count. All right. And then here is the increase function right there. All right. So basically, we just get the smart contract, call the methods with Web3, increase. This looks like just like any other Web3 contract interaction. Okay. And then we just lay out the HTML that connects everything. So we can see all this. Here's the count that's provided. And then basically have a button that has an on-click handler. So whenever we click this button, it calls this increase function, which we defined here. So you can browse through this code and get more familiar with how this works. But I think that's really awesome. So there you go. That's how you create an application that uses the gas station network. Again, we've got a gas station network running on our machine here. We got a blockchain running on our machine. So the next step for you, your code challenge from this video, is to continue on with this tutorial and actually use it on a real blockchain. So you can use it on a test blockchain so that you don't have to risk any real money or anything like that. And you can continue on with this documentation to deploy this project to a test network, okay? And you can make use of a real gas station network. So they've got some nice instructions here on how you can do that. Looks pretty user-friendly. But that's what I'm going to leave to you as an exercise. And then after that, they've got some really nice kind of next steps for you as a developer on how to use like the gas station network starter kit in your own apps and some more helpful guides here. All right, so I hope you like this video. That's how you can create gasless transactions in your dApps so that your users don't have to pay gas fees. All right, so let me know what you decide to build with this new knowledge, this new information. Hope you like this video. Comment down below, like the video, subscribe to the channel. And as always, if you want to take that next step to mastering blockchain, you should join the free training over at dappuniversity.com/bootcamp. All right, until next time. Thanks for watching dApp University.